Lesson 3, Identities, Double Angle Theorems. Theory. In this lesson we have to prove that sine 2a equals 2 sine a cos a, cos 2a equals cos squared a minus sine squared a, and tan 2a equals 2 tan a over 1 minus tan squared a. Now we'll use that theorem we got from the previous lesson. So in the first one, number 1, we know that the sine of A plus B is equal to the sine of A, the cos of B, plus the cos of A times the sine of B. Now what we'll do here, we'll just let B equal A. So now we have the sine of now A plus A, which is 2A, equals the sine of A, the cos of A, plus the cos of A, sine of A. And of course that's equal to 2 sine A cos A. Alright, now the second one, similar sort of thing. We know the cos of A plus B is equal to the cos of A cos of B minus the sine of A sine of B. So we'll let B equal A. So the cos of 2A equals the cos of A minus the sine of A, which is cos squared A minus sine squared A. Now there's something else we can use here. We know that and we know that cos squared A plus sine squared A equals 1. So what we can do here, we can replace the cos squared A with 1 minus sine squared A. And that gives me 1 minus sine squared A minus sine squared A, which is 1 minus 2 sine squared A, which you may find useful. And equally we can say that sine squared A equals 1 minus cos squared A. And so we go cos squared A minus 1 minus cos squared A, and that gives me 2 cos squared A minus 1. And they are very useful, those. Finally, part 3, same sort of thing. We know that the tan of A plus B equals the tan of A plus the tan of B over 1 minus tan A tan B. So again we just let B equal A, and we get the tan of 2A equals the tan of A plus the tan of A all over 1 minus tan A, which of course is the result 2 tan A over 1 minus tan squared A. Right, now here are some examples of using the double angle result. First example, we have to prove that cot x plus tan x equals 2 cosec 2x. Now we'll just work with the left hand side. So the left hand side is equal to cot x plus tan x, which is cos x over sin x plus sin x on cos x. Putting over a common denominator of sin x cos x, we multiply this one by cos x. that's cos squared x, and this one by sin x, sine squared x all over sin x cos x. Now we know the Pythagorean result, cos squared x plus sin squared x equals 1, so it becomes 1 over sin x cos x. Now to get the double angle result, what we need to do is to make that a 2 there. So we multiply top and bottom by 2. We get 2 over 2 sin x cos x. But we know that 2 sin x cos x is sin 2x. So it's 2 over sine of 2x. And of course, the reciprocal of sine is cosec, so it becomes 2 cosec 2x, which equals the right-hand side. Right, example 2. It's a bit more involved. We have to prove that sine theta equals cos theta outside of cot theta minus 2 cot 2 theta. Now we'll work with obviously the right-hand side with this one. Okay, it's the right-hand side. Just writing it out. It's cos theta outside of cot theta minus 2 cot 2 theta. We'll leave the cos theta as it is. Now this is cos theta over sine theta minus 2 times. Now cot is the reciprocal of the tan. Now remember that tan 2 theta is tan 2 theta over 1 minus tan squared theta. So we'll just turn that upside down. Write this 1 minus tan squared theta over 2 tan theta. Okay, so now we'll have cos theta over sine theta. Now these twos cancel out. We get minus, now we've got 1 over tan theta. Now it must be a plus, but this tan will cancel out with that tan squared plus tan theta. There's all sorts of different ways of proving these things, so if you've got another way of doing it, that's fine too. Now it's cos theta over sine theta minus, now this is going to be 1 on 10 is cot, which is cos theta over sine theta, and this is plus sine theta over cos theta. Okay, which is equals, these two go out, and you get cos theta times sine theta over cos theta. The cos's go out, and you get sine theta, which of course is the left-hand side. Therefore, right-hand side equals the left-hand side. Now, in the third example, we're going to prove that sine 3 theta equals 3 sine theta minus 4 sine cubed theta. So we're extending the double angle to the triple angle. Now, to do this, we'll go back to our lesson 2, where we know that the sine of theta plus phi is equal to the sine of theta, the cos of phi, plus the cos of theta, the sine of phi. And we're going to let phi equal 2 theta. So now we'll put a 2 theta in there, we'll get our sine 3 theta. So the sine 3 theta is equal to the sine of theta, this will be the cos of 2 theta, plus cos of theta, sine of 2 theta. Okay, now what I'm going to do now, I'm going to replace the cos 2 theta by 1 minus 2 sine squared theta. Remember that useful thing we proved before? And here we'll write this as cos theta. This has to be 2 sine theta cos theta. Messy, sorry. Now this becomes the sine of theta minus 2 sine cubed theta plus 2 sine theta cos squared theta. Now, using that Pythagorean result, sine theta minus 2 sine cubed theta plus 2 sine theta into, now cos squared theta is 1 minus sine squared theta. So we're almost there. Sine theta minus 2 sine cubed theta plus 2 sine theta minus 2 sine cubed theta. And that will give it to us now. We get, collecting like terms, there's our 3 sine theta minus our 4 sine cubed theta.